Welcome to today's class. Our unit today is business calculations and statistics. And our topic today is measures of dispersion. Last class, we already discussed one of the methods of measuring or calculating dispersion, which was we did with range. And today we are going to tackle quartile deviation. So that's what we are going to tackle today, quartile deviation. And we'll start by just defining or making a definition of what is quartile deviation. So basically, quartile deviation is also known as semi-interquartile range. So it's also known as semi-interquartile range. So you can also call it semi-interquartile range. Yeah? So basically, this measure of dispersion, this measure of dispersion is based on the upper quartile, so which is Q3, and the lower quartile, which is Q1. Yeah? So the upper quartile, we call it Q3, and the lower quartile, we call it Q1. Yeah? So the difference between the upper quartile and the lower quartile is called interquartile range. Yeah? So the difference between the upper quartile, that's the Q3 and Q1, we call it semi-interquartile range. Yeah? And one half of this range is called quartile deviation. Yeah? So one half means the quarter, so what we call quartile deviation. So we are going to write the formulas which are used when we are calculating the quartile deviation. So we'll start by interquartile. Start by interquartile range. So which the formula is equals to Q3 minus Q1. Then we go from the quartile deviation. Okay, so which is equals to Q3 minus Q1, Q3 minus Q1 divided by 2. Then we have the coefficients. We have the coefficients of quartile deviation, which is equals to Q3, Q1 over Q3 plus Q1. So those are the formulas which we are going to choose. They depend on what the question is asking about. So also the reason we are divided by 2 the quartile deviation, because we say there is also called semi-interquartile range, and so on. So that's what we are doing. So basically, when you calculate, basically the difference between the quartile deviation and the coefficient of quartile deviation is that quartile deviation is the absolute measure of dispersion. So quartile deviation is the absolute measure of dispersion. So while the coefficient of quartile deviation is a relative measure, so that's a reason between the two. This is a relative measure. So once you do your calculations, the figure you normally get there. If you get a very small figure, so when you are doing your calculation for quartile deviation, so when you calculate quartile deviation and you find your quartile deviation is a small number, is a small figure, so it describes high uniformity or small variation. So that's a small variation between the two documents, between the Q1 and the Q3 and the Q1. That's what we are talking about. So, but if you calculate and you get a high value, then it means that the variation among the central items is very high, so or it's large. That's what we mean. So it depends on the question answer we get. So from there, we are going to do the calculation, or we are going to calculate or do our calculation for how we calculate. We have given the formulas. So the first question you can get is when we have individual series. So an example of individual series. So that's what we call a group data. So example, find the value of quartile deviation and its coefficient from the following data. So this data is max 20, 28, 40, 12, 30, 15, 15. So basically, that's what we are talking about. So using this information, you look for quartile deviation and also you look for its coefficient. So basically, now how to solve this? First of all, you arrange the data which you have been given into ascending order. So if you have to arrange into ascending order, this is 12. We take the smallest, which is 12. The next one after that, which is 15. So after 15, we have 20. So after 20, we have 28. So after 28, we have 30. So after that, we have 40. Then 50. So we have arranged that data into ascending order. So from that information, now it will help us now to know what is Q1 from the data which has been given there. So we have been told it's the lower quartile. So, but we have to use the formula. So how do we get this size? So size of, so we use the formula. So n plus 1 divided by 2. And you use n plus 1 when you want to get a whole number. Right? So we normally plus 1 when you want to use sorry, this divided by 4 times. Right? So when we want to get a whole number, is when we plus 1. So here our n item, so it will be 7 plus 1. So you count 10, 1, 2, 3, 4, 5, 6, 7. So plus 1 divided by 4. So this will be 8 over 4. So basically, that's what. So if you divide this by this, we get 2. So it is seconds. Okay, so the second item. So if you are looking for, so you come here and count 1, 2. So Q1 is equals to T. So that's what if you remember the concept of median. So that's what you look for the n item. So that n item is what will help us get the number which we need. The quartile, the Q1, the lower quartile. So it's quartile means the lower quarter. So that's what we mean, the lower quarter. So now how will we get also the size of Q3 or the Q3? So it's equals to 3 brackets n plus 1 divided by 4. So that's what we are talking. So our end item here equals to, so it will be 7 plus 1. So that's 3 divided by 4. So that's what we mean. So here it will be equals to, so it will be 3 into 8 over 4. So when you calculate, you get 6. So it will be 6th item. So our name is 6th item. So the 6th number or the 6th item, the 6th item in our data set. That's now we count here 1, 2, 3, 4, 5. So this is the 3, 1, 2, 3, 4, 5, 6. So Q3 is equals to 14. Q3 is equals to 14. So now we have done that. Now we go again to our formula. So we say the quartile deviation. How we calculate quartile deviation? So someone from there is quartile deviation. So yes, we have said quartile deviation is equals to Q3 minus Q1 divided by 2. So already we have our figures. So just go straight away. Now get our Q3, which was 40, and as our Q1, which was 50, divided by 2. So that's what we are talking about. So someone with that mathematics, with that calculation, with me. Okay, yes, so you have said Yes, so basically 12.5 points. 5. So is our answer. 12.5. So once we do that calculation, we get a quartile deviation. So we have in our question asked or say we look for the quartile deviation and its coefficient. So we have already also coefficients. Coefficient of quartile deviation. We are here, so we have already finished. So coefficient. Quartile deviation. So we have said is Q3 minus Q1 divided by Q3 plus Q1. So once you already know the formula, then things are always easy from there. So we have our figures. So Q3 is 40 minus Q1, which is 50 over 40 plus 15. So this one, someone do the calculation. Easy. Okay, so this is 0 points. So this one will be just 25. So when you minus, it will be just 25. 5. So which combined your answer is okay. So that's the answer which you are going to get there. So I hope we are together. That's how you calculate quartile deviation for individual series or for ungrouped data. That's what we're talking about. Okay, so let's proceed to the next example where we have a discrete series. So we are going now to calculate an example that you have been given. Discrete series, so quartile deviation. So the second one is quartile deviation or discrete. This. So that's what talking about. So quartile deviation for discrete series. So an example, compute quartile deviation and its coefficient. Okay, so I think we are good to continue. We are going to continue. So we have said we want to calculate quartile deviation for discrete series. So an example says calculate or compute quartile deviation and its coefficient from the following data. So it's given us data that is marks. Then number of students. So using this here we have 10 or 27. Okay, so 30, 15, then 40, 8, then 50, 7, then 10, 2. So that's what I'm talking about. So using this information, now we compute for the quartile deviation. So from here, now when you get a discrete series, you have to look for cumulative frequency. So cumulative, so this is our x, this is our f. So I just compute cumulative frequency. So you compute cumulative frequency from that information which you have been given. And how do I get cumulative frequency? I get the first figure on frequency. That's why we have said the number of students means frequency here. So then I'll get this plus this here. So to give you give me 11. So 11 plus 15. So that's what you're talking about to give us 26. So I'll get 26 plus 8. So this is 8. I'll get 26 plus 8. So 26 plus 8 will give me 34. Then I get 34 plus 7, and it gives me 41. So then for this should be 43. So that's what we're talking about. So we go back to our formula, how we used to get Q1. So we shall just use the same. So you have said our formula is n plus 1, but we only add 1 because we want to remove the decimal number. So mainly it's supposed to be n over 4. So our formula is supposed to be n over 4, but you just add 1 so that should help us get our number. So if I want to, but the main formula is supposed to be n over 4. So, but you only add 1 so that you can actually remove the decimal point. So, or we get a whole number. So I don't need basically to use, but I can still use so that I get a whole number. So I can just say n plus 4, I get a whole number. So in this case, we normally check the last number of the cumulative frequency to help you get the nth item. So we still don't have Q1. So how do I get this nth item? I use n plus 1 using the last figure in the cumulative frequency. And since it's an odd number, so we normally have 1 close of the odd number so that it helps me to get the whole number. So or whichever, so it will be 43 plus 1 divided by 4. So that's a 44 divided by 4. This is 11. So basically, this is the 11 item. So look for the 11 item from data. So how do I, this is different from the individual series. So how do I get it from here? I come to the cumulative frequency and I look for a number which is 11 or a number which is close to 11. And it should not be less than that number. So it should be either that number or any other number which is above it. So if you look at our cumulative frequency, you can see 11. So this is the area which I want. So then now it will help me get now what is my Q1. So our x is where we want. So it is equals to 20. Our Q1 is equals to 20. So let me repeat again. So we use what we find the nth item, which will help us get our Q1 where it is. So you take n plus 1 over 4, and we have said you only plus 1 when you want to get a whole number. So especially when the last number is a odd number. So it's not a must to add 1. So the formula is n over 4. So then you get 43 plus 1 divided by 4, you get 44 divided by 4, and get 11th item. So I look for this 11th item where it is. And how do I get it? I look at the cumulative frequency, one number which is 11 or close to 11, and it shouldn't be below that number and above. So then now using the same information, let's do Q3. Using the same information for Q3. Q3, you'll see it's 3, it will value n plus 1 by 4. So just going to get out 3 plus 1 divided by 4 brackets by 3. So that will give us 3, 2, 4, 4. So when that will be 3, 2, 7, which will give us 3. So that's what we are talking about. To give us item. Okay, so that's our nth item. So this will now go to the same table using the cumulative frequency, and we look for a number which is 33 or close to 33. If you look at our table, we have 34 there. So and we are interested in where 34 lies, then we look for x up there. So our Q3 is equals to T. 3 equals to K. So we have understood. So then now, how we get coefficients, quartile deviation, that is quartile deviation, now we go back to our formula. So quartile deviation, we say it very well, say Q3 minus Q1 divided by 2. So that's what we want. So we have a 40 minus, so our name is gotten 20. So our Q1 divided by 2. So this will be 20 divided by 2, which is equals to 10. So our QD, our quartile deviation, is equals to 10. Simple as that. So using the same information, then now we look for its coefficient. So the question is we also look for its coefficient. So coefficient you're saying is the Q3 and that's Q1 to Q3 plus Q1. So from the information which we have, 40 plus 20, 40 plus 20, which will give us 20 or 60. Okay, so that's what we are saying. So okay, so this will give us the points to be 3. So that's what we are talking about. Simple as that. So the only simple way to get it is getting Q3 right and getting Q3 correct. That's the upper quartile and the lower quartile. Very good. So yes, you can see you understood. So let's go now. We look for quartile deviation for group data. Now, the exam can bring any of them, so it can either be group data or ungroup data or discrete series. So that way, for group data, we for quartile deviation, the group data. So basically, group data is where we have a large amount of data. So we have to group it into groups. So, example, compute quartile deviation and its coefficient from the following data. Compute quartile deviation and its coefficient from the following data. So the data is given to us like that. So okay, so 10 to 20 is 12. Okay, so 20 to 30 is 19. 30 to 40. 5, 40 to 50, 10, then 50 to 60, then 9, then 60 to 70, so 6. So thinking about, so they have said the group data, what we call continuous is continuous series. Continuous, one continue. Continuous series. So if you want to use that information, so to look for continuous series. So we have said just go straight away, find cumulative. See, we go straight away and look for cumulative frequency. So the same way. So here we have said we check the first number, which is 12. So give me the next number. Okay, at 1. So we does this, this we get at 1. So at 1 plus 5 is 36. So from there, we do the next 46 is 6. And then from 46 is 55. Then 55 plus 6 basically is 61. So that's a figure which we're talking about. Okay, so that's what we are talking about here. So that information is just to help us to get our end item. So we still use the same formula. So sorry, not the same formula. There's a now we get Q1. So but this time we need to get the Q1 first. Then we show you the formula for continuous series. So it's not the same formula we use for the discrete series. So this is different. So, but the size of our n item, so size of our n item still remains the same. So n over 4. I've said the formula is n over 4. We only add 1 if we want to remove the decimal. Now, sorry, we want to remove decimal basically to get a whole number, but not a must. So we want to get our nth item, so which will be, we have said we pick the last number, which is 61. Okay, so I can get 61 over 4, which will give me 15.25. So that's what it will give me 15.25. So this if I was to add +1, give me a state decimal point, so I will not see the need of adding +1. But I've said the formula is n or 4 to help you to get the n item, and so on. So now, how do I get the formula for Q1 now? It will be L plus I over L into brackets n over 4 plus speed. Then bracket. Now that's a formula which we are going to use there. So you are just seeing figures. Sorry, you are just seeing numbers. What are these numbers? Not numbers. What are these alphabets? So L means lower class boundary. So this one, lower class boundary. This is the lower. This is the upper. Lower, upper, lower, upper, lower, upper. So we want the lower class boundary. Then I means the class interval, that is 10 to 20, 20 to 30. If you see it's 10, 10, 10, that's what we mean. Then this is the frequency of now the quartile we have gotten. So our whatever, remember we are using the same process we used in the discrete series. So that's the class quartile, that's what we want. So the frequency of the quartile class. Then n, the n item, okay, which you have already found there, 15.25. Then C is the cumulative frequency. Okay, so basically the same so on. So the cumulative frequency, that's what we're talking about. So let's say so Q1 is equals to, so first of all we have found 15. So here we look for a number which is 15, or yeah, 15. So that's what we want to get along. So we want to get along with that. So that's what we want. So we need to ask ourselves, is 15. So this is the quartile plus. So that's what we want. So yeah, so yeah, so it's 31. There's no any other number. So it's 30. 31. So then now, if you get that, or L 20. Okay. Class. Now our class interval we have said is 10. The frequency is 19. Okay, so into brackets n, you already found it, which is 15.25 divided by 4. So C, we have said is the cumulative frequency preceding the quartile class. So which will be 12. So this one. Okay, so you want the this one, sorry, is the frequency, the seeding, the frequency of the time plus what we are saying. So then from there, just do the ball mass, give me the answer. Okay, so yeah, yeah, it's 21. 1 inch, 1 inch, 7, 1. So that's what I'm talking about. So just simplify. Now we have our Q1. So now using the same information you want to look for. So let me write somewhere. Q1 is equals to 1.7, 1. So now let's look for Q3. Q3, remember say Q3 is N1. That's the formula for getting the nth item for Q3. So to help us to get the n item. So it will be 3 brackets 1 divided by 4. Okay, so which will give us this 5, 7, 5. So this is our nth item. So we go to back to our calculated frequency. We look for a number which is 45 and 75, or a number which is closer, which is 46. So that's what the 1, 2. So now our Q3 is equals to, so now the formula, so you still use the formula L plus I F brackets 3N 4 plus C. So that's what the talking about C. So fuse. So just want this one to stick very well. Yeah? So C is the cumulative frequency, the seeding, the quartile deviation. So for example, here it will be 36. Eh? So I think I need to make a correction. The other one I said is this one, but it is this one. Eh? So then just using our formula. So we will continue. So L will be 40. So the lower class boundary, I is the class difference. Okay, F, which is the frequency. Okay, so F is there, the frequency. So into brackets, already gotten our 3N. So basically, that's what we want to look for. So we calculate. We got our end item there, so we need to calculate. So our end item it was 3 into 61 over 4. So already we got it, which is 45, 37, 5. So then according to our formula, we divide it by 4. Divided by 4. Then what do we do? Yes. C. So we have said C, you can see the seeding, the quartile deviation plus, so on. So which in this case 36. Okay, so using ball mass, calculate and give me the answer. Yes, so basically 0 points, 14 points, 2. That's what talking about. No, you are wrong. Answer. Anyone else? Yes, 49. 7, 5. That's it. Answer. So don't confuse. If you don't use ball mass very well, then you will end up getting the wrong answer. So we still have now our Q1 and our Q3. So now we don't need this information any longer. So quartile deviation equals to Q3 minus Q1 over Q3 plus this for coefficient. So by 2. So we have our Q1 and Q3. So Q3 is 49, so it's 25 minus 21, it's 71 divided by 2. So someone give me that answer. Also another person, so to do the coefficient, coefficients, quartile deviation, we have said is Q3 minus Q1 divided by Q3 plus Q1. So in this case, it will be 49, 75 minus 1, 71, 49, 75 plus the 1. So also another person without calculation. What did you get? The first one. Okay. So what did you get in the first one? Still waiting. Yes. 14.02. Okay. So 14.02. One was gotten the answer for the second one. Coefficients 0.92. Okay, so that's the answer. Okay, so just to give an overview, so that's how to calculate quartile deviation. So we have said basically how to calculate quartile deviation. There are 3 ways you can get a question either as an individual series. You can get a question also either given discrete series or given a continuous data. That's what we call grouped data. So all of those examples or questions, the only thing we need to look is we look for the upper quartile and the lower quartile. So once you get that information, then now it will be good to answer that question. So we want to wind up so that now if there's anything we did not understand, you can ask, because I've done quite a elaborate. So know the area which you did not understand very well and not to get confused. We talked about the C in the continuous, when we are looking for the for Q1 and the Q3, the continuous data. I've said very well. C is the cumulative frequency preceding the quartile deviation plus frequency of the so don't confuse. So and the F is the frequency of the class quartile deviation. So that's what it says. So don't confuse there. So the C and the F. So the, on your cumulative frequency, the number which is preceding the class quartile deviation, that's what you pick. So if you don't have any question, then we can call it a day, and we meet in the next class where we shall also discuss another method of calculating measure of dispersion, that is the standard deviation. So today we are going to end our class there. Meet in the next class.